Okay, let's look at practice 3D, problem number 4, because that one's a little bit different. So for number 4, it says a person standing on a cliff throws a stone with a horizontal velocity 15 meters per second. So when we write our given, we're going to separate and write our x and y given. And we know ax is always 0 and g is equal to negative 9.8 meters per second squared. We know that the initial velocity is 15 and the stone hits the ground 47 meters from the base of the cliff. How high is the cliff? So we want to find y. So it helps to draw a picture. The picture, we're going to establish our sign convention, and where motion begins is our frame of reference. So here's the top of the cliff, and the object is thrown like this. It's all horizontal, and they tell me that VI is equal to 15 meters per second. Okay. They also told me that, so first of all, this is all horizontal. It has no vertical component. Okay. So I know VI is equal to VIX. So VIX is equal to 15 meters per second. And VIY is 0 because it's all horizontal and it has no vertical component. In this problem, they tell us X is equal to 47 meters. And they want us to find Y. So how do we know where to start? We always know where to start because we look at each side of our given and it says, where do I have 3 things? If I don't know where to go, I go to the end and I want to find Y. So I could think about which equation has Y in it. So the easiest way would be to do what we did in the other problem and find Y. The problem is we don't have the time. Remember, if I find the time here, that's going to be equal to the time here, and then I would have 3 things on this side. So I have 3 things here. I have AX, I have BIX, I have X, and I want to find T. So I'm going to say which equation has those 4 variables. Now our basic equation is X is equal to VIXT plus 1/2 AXT squared. But we know that AX is always 0, so this whole term goes to 0. We're not memorizing new equations for projectile motion. We realize that we're using the same exact kinematic equations that we used for one-dimensional kinematics that we're using here for 2, but because there's never any horizontal acceleration, because once the ball leaves, there's no longer an acceleration on it. Once it's traveling through the air, this whole term goes to 0. Now I want to find the time, so I'm not going to just plug numbers in. We're going to rearrange the equation to solve for the unknown in terms of the known. So T is equal to X over VIX. Remember, these are subscripts. So T is equal to 47 meters over 15 meters per second. So on my calculator, 47 divided by 15 is 3.133. So we'll say 3.1 seconds. Now remember, in physics, you always have a foolproof way to check your work every time. because if you carry your units through and cancel them, it's a way to check your algebra. So a meter divided by a meter per second is the same as a meter times a second over a meter. This cancels with that, and I see seconds is the correct unit for time. And I can just do that when I look at it. Okay, so we still want to find y. So our basic kinematic equation in the y direction, we're using the same equation. This one is applied horizontally, and now we're going to look at one applied vertically. So y is equal to VIYT plus 1/2 GT squared. VIY is 0, so that whole term goes to 0. So remember, we're not memorizing new equations. We're, again, using our same kinematic equation. So it's 1/2 negative 9.8 meters per second squared times 3.1 seconds squared. So if I do that on my calculator, 3.1 squared times 9.8, the negative divided by 2 equals negative 47 meters. So the question is, why am I getting a negative value? I should get a negative value because I'm measuring from here down, which is my frame of reference, and according to my sign convention, because I'm using the same standard Cartesian sign convention and I use in math class, that up and to the right is positive, I should get a negative value. If I want, I can check my units. I have a meter per second squared times a second squared, because when I squared the 3.1, I squared the second. So this cancels with that, and I end up with meters, which is the correct unit. And then I see I didn't make a mistake. So depending on the problem, if you write your given and find in 2 columns like this, you'll be able to know what to do. Where do I start? Because you're going to look at which side I have 3 things on.